Never mind. I was going to make a joke, but it's not worth it. All right, what's going to be on the quiz? Your symbols. Ooh, look at that. It's waking up.
Like the elements?
I haven't even completed the sentence yet. In general, you would lift your hand above your shoulder to indicate that you have a question instead of interrupting the instructor. Also, please remove the AirPods. You don't need them to hear me clearly. So, symbols and names of elements. I've selected 20 for you guys to present to me. So I'll give you the symbol, you give me the name, or I will give you the name and you give me the symbol. Then I will also have you fill out the table of the geometries. So, you should know all of the symbols and names, and then obviously the table of geometries. I've picked symbols and names that are meaningful but also tricky, so study all the hard ones. And make sure you know your geometries. So, if you have 4 electron regions, what geometries can you get? If you have 3, what geometries can you get? If you have 2, what geometries can you get? Yes, sir?
How do I study for this?
You study the symbols and names using the flashcards that you generated earlier for this class, and study the table of geometries.
Are we doing these flashcards
Yeah.
for the quiz?
The symbols and names that you are required to memorize for this class. Excellent question. Andrew.
Okay. Do you remember what page the table of geometry study said we're doing?
No, but they're in your notes from yesterday.
You're going to say that. Okay.
Yeah. Calm down. Take a deep breath. All right. We have need of prayer. Where's our prayer warrior? Michael, would you lead us in prayer, please? Oh dear, the prayer warrior is down.
No.
Okay, you good?
Dear Heavenly Father, thank you for this amazing day that you have created. I pray that you would renew our minds and that we would just work hard so we can play hard. And I pray that Mr. Belanda won't be stressed over us, but be blessed. Just never.
Amen. I like that. I had this former student, send me an electronic message. Andrew, this is answering your question.
Oh, you are?
This student sent me an electronic message, and the message said the following. It arrived digitally. It's called an email. You may be familiar with it. It said, Mr. Belanda, thank you so much. I hope your year is going well. I was wondering if you could send me so-and-so's email address. Period. And then he hit enter a few times, and then there was a new paragraph, and it said, actually, I know what you're already going to say to this email. You're going to say, look it up. I guess I'll just do that. I hope you have a great day. Sincerely, and I'll leave the name off to protect the identity of that person. It's like they knew that I was going to say, look it up yourself, because literally they could just search blah, 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 and then have it. So, I would...
Wait, a former student?
Yeah, a former student.
So they don't go here.
We can figure out who this is pretty easily.
Yeah,
It's
your
there we go, we got it. So, so that's that. So it was quite funny. I was encouraged that I imparted some sort of wisdom upon him. I also, because I laughed and it was funny, actually did reply to the email with the name. If I can find it in the next 3 seconds, I will tell you what page it's on.
I think it's 175.
188. I think it's in the book.
I think it's in the book. That's right.
You just had it.
I know. But I didn't find it in 5 seconds. And it was one
Dude,
of...
you had it. Why? For the table.
That's page 179. So,
Oh, okay, you got it.
we are going to review it now as an extra gift. So,
Thank you.
question.
Are we going to use the study all 52 of these, or is there one that we're going to use?
I encourage, no, just those ones. I encourage you to study the hard one.
I'm so sorry.
Are you okay? All right, we got some spiritual warfare going on in the back here.
Tuesday, isn't it?
You okay?
Sorry, I just heard something funny.
Hello, mate. What happened, Michael?
So, since this is a chemistry class, and chemistry is somewhat the study of living things, I feel obligated to let you know that I did destroy this life form earlier today.
What is it? What is it?
Well,
marked it right here.
Ew, if it's a bug, leave it alone. Oh.
What's his name?
I will have to acquire it using other means. This is gonna be a really funny video to watch.
That's
I feel really bad for-
Put it up to the camera.
Is it recording?
Freak everybody out.
Absolutely.
I missed
Is it alive? It looked like it
That's
jumped.
it. I'm gonna take someone's knife.
Ew.
Sorry, buddy.
Highly unfortunate.
Ooh,
Oh, thanks.
what the heck? You, oh my god.
What's his name?
His name is Sebastian.
What
Yes.
is it? Yes.
Put it up on the camera. So, I destroyed this life form, and I feel like it may be similar to the life form that's bothering me.
That's disgusting.
It's your new lab partner.
Why did it ew, no.
Do you want me to throw? I'll.
Esteban, it's me.
Look at his face, he's so offended.
Sorry. I don't think he's
I
offended.
can clean your sound.
Okay.
What's that? Whatever that is.
Whoa!
Wait for me.
Whoa!
I hope so.
Sorry. Okay, that's done. A little bit of chemistry humor, if I may. Let's bring it back in 3, 2, 1. Okay. Study the symbols and names from the flashcards. Okay.
Thank you.
Table of geometries. You have 4 electron regions. You have 3. You have 2. Okay. We're gonna regenerate the table so that everyone knows what they're doing.
Wait, don't
Yes.
we already have 3?
These are the things you do.
For the symbols and names portion, is it gonna be the
Sorry.
time as it was last time?
There's only 10 of them each. It's fine. Don't worry about it.
Symbols and names?
No, yeah, there's only 10.
There's only 10?
Yeah, I picked the hardest ones. That's fine. Mrs. Kripe said that I should pick the hardest ones and just give you those over and over again. Hey guys, when you're ready to be in class, please be here. Otherwise, step outside. Okay? We're going to move on. All right, good question. So,
Thank you.
4 electrons, electron regions, 4 bonds. We have everybody. Come on. This was like yesterday we did this. Tetrahedral.
I don't remember that.
4, 3.
Pyramidal.
Pyramidal. 4, 2.
Bend of
Bend.
32 degrees.
Bend 92 degrees.
Why is it 92? Because the electrons on top are pushing down on your other atoms. 4, 1.
Linear.
Linear.
You're like that kid at the pledge who like says everything. It's like I pledge, like someone's saying it and then they say it like half a second later. So it fits perfectly in the pauses of the first sentences. You know who you are. Okay, all the 1 ones are linear, so that's easy. Okay, now 3 and 3 is trigonal
planar.
Tetrahedral's only that one, and then 3, 2 is
It's a bend.
It's bent 120.
120.
120. Not bent as much because it has just the 1 pair of electrons on top. 2 and 2 is
Linear.
all the 2 ones are linear. Okay. Cool. So that's our review from there. Done. Let's go over your homework, which was number 14. Number 14. I'll come around to check your homework now.
You know, I can do it.
Number 13.
Time for that.
Was it 13? Was that kind?
Yeah, it was 13.
I did.
It was 13.
It was 13 on
I hope it was
188.
13.
13. So I will come around and check your homework.
That's right.
I don't know how.
Right here.
No words. I'll do it tonight.
It's just one of those days, isn't it?
No, I just don't feel like
Thank you for drawing the arrow that says homework to the homework. You got this, okay? I know it's late in the day.
My eye just itched.
You're at 9 a.m. start time has born on you. You can get as much rest as you need.
That's my homework.
No.
What is it?
Highly unfortunate.
It's just like.
All right, so we are going to move on from there. And let's draw.
Sorry. I'm so sorry. For the, do you have whatever, do you have to draw the pictures? Do you have to draw the pictures?
I wasn't gonna make you, but that's a great idea. I'll add it to your quiz.
No, I was, okay, you know what,
All right, OH minus. So
Yeah.
the quizzes are already printed. We're much too lazy to, by we, it's the royal we of me. Much too lazy to change things. So oxygen, 6 valence electrons, hydrogen, 1. So these guys bond. That uses one of those. The extra electron goes there. Now, the follow-up question is, what geometry will this be? Well, let's look at the number of electron regions on
Linear.
the central atom. You have 1, 2, 3, 4. So there's 4 electron regions. How many bonds are attached? These colors are too small. These colors are too small. How many bonds? This is not a trick question. How many bonds are there in this picture?
One. No.
How many solid lines are on this picture? One.
Wait, actually, there's
1,
2. There's
1 bond.
I have a question.
So this is going to be, I know, just raise your hand. I will respond when I'm ready. Is your hand raised? It's above your shoulder. Oh dear. So from now on in this class, if you have a question, you will raise your hand above your shoulder. If you do not have a question, you may keep your hand below your shoulder. Should we do the top of your head? But then you have to be like that kid all the time. Like, what if I don't answer your question right away? It like goes away. You're like, okay, like picking your earwax out and like flicking it. Okay. So 4 electron regions, 1 bond gives us a linear. Excuse me. Step out. Come back when you're ready. Okay. Okay. What was the dead giveaway that this was linear? There's only 1 bond. Nope. Like, go to get water. Come back. Okay. Take a moment. Okay. Woo. So there's only 2 things. There's no way they can't be in a straight line, right? How many points make a straight line? 2. So as long as you have 2 things, you know it's going to make a line. That's it. Lisa, would you close the door, please? Thank you. So I'm not disrupting those. Never mind. Ryan's back. Okay. Hey, Ryan. All right. Next one. We have boron trihydride. So that is BH3. So remember, boron is on our weird list of atoms. So boron has 5. Do I buy that?
Maybe 4, actually.
I don't buy that. I think boron has 3.
Oh.
Hydrogen has 1. So that's that. Remember, boron was on that list of elements that don't follow the octet rule. That guy only needs 6 electrons to be happy. So what do we do here? Well, we have how many electron regions? 1, 2, 3. And how many bond regions? 1, 2, 3. So we have 3 electron regions, 3 bond regions. So we're going to have a trigonal planar geometry. Questions?
Oh, I have a
Yeah.
question. So for the first one, there's like a negative right there. So why can't we just take like 1 electron from the bottom and use it with the extra electron to make a double bond?
Ooh, good question, because hydrogen only wants 2.
Oh,
So hydrogen wants 2, oxygen wants 6, so just, great question. I like using that sound effect. That's one of my favorites. All right, next one. Hydrogen cyanide, or HCN. Remember, carbon is almost always the central atom. How many valence electrons does nitrogen have?
1. I mean, yeah.
Okay, and hydrogen has 1. So I'll connect that guy, and I'll connect that guy.
Thank you.
Okay, now I see that these guys are unpaired, so I will connect them. Then I see that these guys are unpaired, so I will connect them as well. And because I like things to look neat, I'll put that over there. Neato.
Oh, so it doesn't actually matter where you put it?
No. So, let's look at our central atom. What has, or how many electron regions does it have? How many things does it have around? 1, 2. So 2 electron regions. How many bond regions?
4.
1, 2.
2. So if it's like stacked up.
So you don't count the number of bonds, you count how many bond regions are coming off of it. So this is a bond region because there's a bond going that way. And this is a bond region because there's a bond going this way. Single, double, or triple, doesn't matter. You just count how many different things it's bonded to. Yes?
With the N, then is that nitrogen?
Yeah.
Why did you add another bond? Why didn't you just put the 2 dots on top of the N?
Ooh, good question. So if I had this.
Wow.
Tuesday.
And then I had that, right? Carbon had too.
Yeah.
So the question is, why doesn't carbon just keep its double bond or electron pair and this guy? The problem is that this guy doesn't have 8
Right.
and this guy doesn't have
So
8.
yeah, because then you add one more bond, and then you can just move the one on top of this to the one over on top of the N. And then the one under the C erases. Yeah, and then just add that bottom one to the top. Why don't you do that?
Because then that has 6.
Oh, I see.
Yeah.
Okay.
Good question. Good question. So we have 2 electron regions, 2 bond regions. What does this form? Still linear. Cool. So that is that. Then they give you a bunch of curveballs that don't work. No, that's fun. You can do them. So again, we had that ugly list of things that do weird things, and these are on that list. So PCl5. It's a new marker. Okay, so likely phosphorus is going to be in the middle. Chlorines are going to be around the outside. You usually want what there's more of on the outsides because it'll give you more balance. So we have phosphorus here. How many electrons does phosphorus have?
5.
I think 5 sounds about right. You're thinking chlorine. Chlorine has 7.
I'm thinking fluorine, I'm sorry.
Oh, gotcha. Okay, these are easy, right? And then we're like,
Oh.
It looks like a gem.
So I mean, if it is a thing, then probably connect the dots. So phosphorus is going to take on more than 8. Sorry, buddy.
Is that possible?
Yep,
But then where's
It's just a
bond thing would go to?
Does it follow the octet?
it doesn't.
Is it one of those excluded ones?
Yeah, I mean, if you mess with things enough, all of them can be excluded. It's like people. You're like, no way. I can't believe that there's ever a person who has an extra finger, right? And has 11 fingers. And then you meet one and then you're like, oh wow, there's so many people out there that eventually somebody has to have 11 fingers. Somebody,
You had 11 fingers?
huh? Usually it's another people.
Does that mean Adam or Eve had 11 fingers?
It's just like.
No, it means that eventually it's gonna happen, right? And so you have all of these elements and they're mixing in all sorts of different conditions. And so eventually you're gonna get weird stuff. Not that people with 11 fingers are weird, they're just different than the normal that we're used to. One of the nicest people I know only has 7. She has like a full hand, and then she doesn't have the 3 middle ones, and so she's able to grip things. She's super cool. So that's that. So anyways, next we have SF6. So again, sulfur was one of the weird ones. That's fine. Sulfur does weird things. You'll notice that they're doing weird things for the halogens because the halogens are so hungry for that extra electron. So yeah, they're kind of bullies. Sulfur has 6, and then we have 6 fluorines.
Oh, wait.
So they're just gonna bond. Okay. Yeah.
Oh, you did. It's a tetrahedral for the number D.
No, these are all different weird ones that you can't name.
Oh, so I don't.
Yeah. I mean, you can name them, and they do have geometries, but they aren't the ones that we're learning, and they're beyond the purview of this class. So D is actually a trigonal bipyramidal. So it's going to make 2 pyramids, which is kind of weird. This one is octahedral, and then this one is going to be T-shaped, it said, not like the gossip. So chlorine trifluoride. So you have chlorine, and then you have a bunch of fluorines outside of it.
You're hitting so hard.
I remember back in some of your 7th grade, some
Why
of
are
you.
markers getting pushed down? I don't know.
That is exactly what the conversation was.
Do you remember, like, everyone was having serious talks with us because they were like, you guys, you need to respect their property and not push down the markers.
That's true. We had those talks. Let's do that. So, after a while, I think this one's in there just to show that sometimes they're just impossible. I know who it was.
Yeah, it's a lot of people.
Yeah, no.
I know who it was. It's okay. So, we're moving on now. Okay, so that was your homework. We already went over the geometries, so I don't have to assign number 14. Question? If you have one, please elevate your hand above the top of your head. Yes?
I think that was supposed to be, I don't think I'm seeing things from my pocket.
I don't know. My drawings exactly match the answers provided in the book. Yeah, I mean, well, they're right here. So, all right, so we left off yesterday talking about polar bonds and polar molecules. So let's go back to our table here and talk about which of these can be polar and which of these will likely not be polar. Okay? So a tetrahedral will be polar if, are you ready for that? You guys weren't ready for this, huh? For me to like extend your notes.
Polar.
Polar, question mark. Yeah, polar. Will it have a positive and negative? Yes. Yeah. Will it have a positive and negative side? Here's how you can kind of tell. Okay, so let's draw out the tetrahedral again. So you have your central atom, and you have a bunch of outside atoms. The drawing. You got this. Like a little tripod, right? with the little, whoa, that missed. It's like Mevo, right? It's got like the 4 bottom and then Mevo is sticking up. Now, this will not be polar if all of these outside atoms are the same. But if these guys on the outside have different electronegativities, then it will be polar.
Are there things smaller than the atom?
Generally, the central one should be, nah, they can all be different sizes.
No, I'm just saying, like, are there things smaller than atoms?
I mean, protons and electrons,
Okay.
because they make up atoms.
So 7th grade lied.
I'm sorry. All right, so the idea is if these are all the same, you have the central part, which probably has a different electronegativity, and then you have the outside ones that are about the same or the same, then it's not going to be polar. Because when you look at it from a zoomed out perspective, you're going to see 4 things on the outside that have the same electronegativity. It doesn't matter what the thing inside is. It's like the Earth, right? Like you've got the outside, crazy stuff is happening inside, but like the outside is fairly habitable. If you like dig down to the center, you melt to death and die, right? Like, so overall, this is not going to be polar unless these guys are different. So if you have one that has a different electronegativity, let's say that atom is different than those 3, then it could be polar. Okay, you would either have that side more positive or that side more negative. Okay. What about the pyramidal? What do you guys think? So here's our picture. Polar or non-polar?
It could be polar.
Probably polar. Yes. Okay, it's always polar. Why? Because you have these electrons hanging out here. You probably have a different central atom than the ones it's attached to. So these guys down here are most likely going to have a different electronegativity than the guy at top. So if you look at this overall, you should have one side that's more negative and one side that's more positive. Okay. I think the example of pyramidal from our homework, we didn't have one, from our lovely table on page 179. You know who you are.